So for this problem, we want to find, we're going to reference this graph to find f of -3. So that -3, again, is an input value. So I can go here to the graph. I'll go over 1, 2, 3, -3, and I'll go up to here on the graph. And I can see that the corresponding y value is 1, 2, 3, 4, 5. So f of -3 is 5. Okay. And then f of 4, again, I'll go 1, 2, 3, 4 over in the x direction, and I'll look down here, and the y, corresponding y, is -6. Okay. So then the next thing says, for what values is of x is f of x equal to 2. And so I can go across here, and this is where f of x is 2 is a y value. And so what I can see is I see two places where my function value is equal to the y value 2. And so, so the values are x equals -2 and x equals 1. Then it says, for what values is f of x greater than 2? So I want to look at where the function f of x is above the graph. And so I can see it's this portion of the graph is where the y values are greater than 2. And so that happens for the x values starting at -5, except that's an empty hole there. So we'll do starting at -5 with an open parentheses, and ending at -2, and we'll do a closed parenthesis on that one because we have a closed dot there. Oh wait, no, it's strictly greater, never mind. So then it would be actually an open parentheses. So we'll open that, there we go. And then find the domain and range. Okay, so the domain is all the possible, So the domain is all the possible input values. So I want to look at this function and see the possible x values for which my function is defined. You can see my function is defined starting at -5 to 4, it looks like, for the domain. And then I'm going to do an open parentheses on -5 because that -5 is not included. And the 4 has a closed dot, so I'm going to do a bracket. So this is the domain. And the range is this, so these are all x values here. And the range is going to be the set of all possible y values that my function hits. And so I can see the greatest y value is at 5, and the smallest one is at -6. And even though there's a dot there at that -5, it is achieved here at this value. So that -5 actually is going to be included because it is a possible output. So the set of all possible outputs are -6 with a bracket to +5 with a bracket there. And these are the possible y values that the function achieves. Okay, so next one, I want to find these f of a plus h minus f of a over h. So what I want to do here is I'm going to plug in this a plus h for my input value. So that's going to go in here for x. So f of a plus h is going to be 3 minus a plus h squared. And then I'm going to do minus. And now I need to do f of a. So that means I'm going to take this a value and plug it in for x here. So I'll do f of a is equal to 3 minus a squared. And you've got to remember these parentheses here because we're subtracting all of f of a. So you have to subtract the whole thing. And that's all over h. And now I just want to untangle this. So I know, we'll go over here to the side and we'll do a plus h squared is going to be a plus h times a plus h. And so that gives me a squared times a8, or plus ah plus h squared, which gives me a squared plus 2ah plus h squared. So this is going to go in place of that. So we'll go ahead and simplify that. So I'll have 3 minus a squared plus 2AH plus H squared minus, and I'm just going to go ahead and distribute that negative sign here into both of these. And so I'll have minus 3 and then minus negative A squared, so plus A squared all over H. And then again, I can distribute this negative sign into all those guys here. And so I'll get 3 minus A squared minus 2AH minus H squared minus 3 plus A squared all over H. And if I look at that, I can see some of these terms add to 0. So I can see there's a positive 3 and a negative 3. Those add to 0. And then I have a negative A squared and a positive A squared. And that looks like that's it that I can match up there. So I end up with that 3, the 3's are gone, the A squares are gone, so we end up with negative 2AH minus H squared all over H. The next thing I want to do is look in the denominator here for common factors. And I notice that both of these have H's in them, so I'm going to pull out that H. So I'll have H times negative 2A minus H all over H. And then I know that H divided by H makes 1. And so I can reduce that to be negative 2A minus H, and that is my solution. So the first thing is it asks for the coordinates of P and Q. So the coordinates of P, the x coordinate is B and the y coordinate is A. So the coordinates of P are B comma A. And the coordinates of Q are, the x coordinate for Q is D, the y coordinate for Q is E. So D comma E. Then it says evaluate f of B. So if I want to evaluate f of B, I want to go over here to the B and I want to go up and see the y value that corresponds to that. F of B is equal to A. And then it says I want to solve f of x equals E for x. So that E is a y value. Okay, and so if I look along here, so at the y value E, when does the function hit that y value E? Well, it hits it here at x equal D. The next one says, suppose C equals f of z and z equals f of x. What is x? Okay, so we don't know what z is right now, but we know it says C equals C equals f of z. Well, what is C is here, this y value here. And it's f of, if I look at the x value that corresponds, we can see that z is 0. We know C equals f of 0. So that tells me that z is equal to 0 here in this case. And so we have 0 equals f of x. And so that's a y, this 0 here is a y value. So if I go over to my function here and I look at the y value 0, at what x value does the y value hit 0? And that is at x equal h. So now it says, suppose that f of b is equal to negative f of d. And we want to see what we can conclude from that. So what is f of b? F of b we have said is a. So a is equal to negative f of d. Well, what is f of d? F of d is e. So this tells us that a is equal to negative e. So that's what we can conclude. The next thing, we want to find the domain of this function. And so when we're looking for domains, we want to see that that's the set of all possible inputs. And what I mean by possible inputs is they're inputs that give us a defined output. So when I look at this, well, I can square any number that I want. I can multiply it by 8. I can add and subtract any number that I want. So the domain here is all real numbers. So I can say anything from negative infinity to infinity can be plugged into here and we'll have a real output. However, if I look at this one, I have a couple of issues because I know that the denominator can't be 0. Can't equal 0. And I also know that underneath the square root, cannot be negative. If I'm looking for a real number output, I can't have a negative under the square root. So if we can translate those two things into something, I know that x plus 1 cannot equal 0. So x cannot equal negative 1. So that's something that I have to throw out of my domain. I also know that x plus 5 needs to be positive. Well, or it can be equal to 0 too, because the square root of 0 is just 0. So I can do x plus 5 is greater than or equal to 0. That means x is greater than or equal to negative 5. And now I think it might help, especially since we have these negative numbers, to put this on a number line and see what we get. So negative 5 would be over here in relation to negative 1. And so what we want to do is we want to say all the x values that are greater than or equal to negative 5. So if I'm going to draw that, I'll draw it in yellow here. So greater than or equal to negative 5, but I want to throw out negative 1, so we'll do an empty hole there, and we'll do like that. And so once you see it on a number line, that can help you write it in interval notation. So I can see it's going to consist of 2 intervals because it's broken up by that negative 1. So I'm going to get close bracket, negative 5, comma, negative 1, open bracket, union, negative 1, comma, infinity, open bracket. So for this function, I want to sketch a graph of a piecewise defined function. So the first thing I think you ought to do is take a notice of these pieces here. I can see that my graph is consisting of 3 pieces, and it's seeming like it's broken up here at 0 and 2. So it's almost like we can think of this as happening in 2 different pieces. I'm going to put a dotted line here at 0 and a dotted line here at 2, and I'll have 3 parts of my graph that I want to graph here. So the first part of my graph is at 2x plus 1. That's a linear function. I can see this is my intercept. My y-intercept is 1. And the slope is 2. So if I go back 2, I'm going to go down, back 1, down 2. So I've got these points on my graph for my slope. And so I can draw it like that. And then and that's for x greater than or equal to 0. So I know I have a closed dot there. And then the next part of my graph says it's just a constant function, which would be a horizontal line at y equals 3. So we'll go up 1, 2, 3. And I have an open dot there because it's strictly less than, and also strictly greater than 0, strictly less than 2. So I'll have an open dot here as well. But I just have this horizontal line at 3 for that portion of my graph. The last bit of the graph is going to be at negative 3x. And that's going to be a closed dot there. Okay, so let's think about this for a minute. So where is this graph when I am at the value x equal 2? So if I plug in 2, I'll have negative 3 times 2 gives me negative 6. So, so my function is down here at negative 6, and it's going to be a closed dot. And then the slope then is negative 3. So if I go over 1, I'll go down 3. So it looks like that is the graph. And so now I have graphed each of those 3 pieces of my piecewise defined function. So this red portion here is the graph of that. The next part says I'm given a graph of a piecewise function and I want to find a formula for that function. So I can see first of all that it occurs in 2 pieces, and so I can fill in that part of my graph. So one part of it goes from negative infinity to, it looks like at x equal 1 is where it breaks and changes to a different graph. And so I can say x is less than 1. And if I notice that at 1, it's going to be that top function. So I'll do less than or equal to 1. And so we'll figure out what the equation of this portion of the graph is here. The other part of the graph I'm going to make in blue, we have an open dot there, and it's this constant function. Then that one's going to be pretty easy. So that is for x greater than 1. And it looks like it's just a constant function at y equals 2. This top part of the function, let's see here. So I want to graph that, or I want to find the equation of that. so I can see my slope here. Let's see if I go, where does it kind of go through the graph again? Right here. It looks like the rise over run is 1, 2, 3 over 1, 2, 3, 4. It looks like a positive slope. Slope there, so m is equal to 3 over 4, and so I can find a point on my line. I know that a point on my line is x1 is 1, y1 is 4. There, that point 1, comma 4 is on my line. And so if I do y minus y1 equals m times x minus x1, which is my point slope form, I can do y minus 4 is equal to 3/4 x minus 1. And so I can write that down here as my formula. So 3/4 x minus 1 plus 4. So now we have a pizza restaurant charging $4 to deliver a pizza if the location is no more than 3 miles away. And then they charge $1.50 for each additional mile for a maximum distance of 10 miles away. So it looks like they're not going to deliver if you live more than 10 miles away. Okay, so the first thing I want to do is write a piecewise function for the cost of delivering a pizza X miles. So it seems like that we're doing one thing for the first 3 miles, and then after 3 miles, we're doing a different way of computing that function. So, so the cost as a function of x is going to be in 2 pieces. We have something for 0 less than or equal to x less than or equal to 3 miles away. And then we have for x greater than 3 miles away. So when we are in between 0 and 3 miles, the charge is just $4. So we can put a 4 there. And then after that, it's going to be $1.50 for each additional mile. So it's going to be that $4 plus, I want to do $1.50 times the additional miles. So for instance, if I'm 5 miles away, then I would do 5 minus the original 3 miles, and I'd have 2 additional miles. So what we're doing there is we're doing x minus 3 to figure out how many additional miles we are adding, and that number of additional miles is going to be multiplied by the $1.50. And so that is our function there. Then I want to sketch the graph. And so for the first 3 miles, it's $4. So I can draw that here. And then after that, I'm going to proceed with a slope of 1.5. So that means if I go over 2, I'll go up 3. So it looks like 5 miles away is $7, and so on. And then at $10, we stop. So let's see here. So what is the cost at 10 miles away? Sorry, 10 miles away. So it's going to be 4 plus 1.5 times 10 minus 3. Yeah. And so 10 minus 3 is 7. So 4 plus 1.5 times 7. And that gives us, let's see, 4 plus 1.5 times 7, 14.5. So at 10 miles away, the charge is $14.5. It's pretty expensive for delivery. All right, so there's my graph, and then I wanted the domain and range. So the domain is all the possible inputs. The inputs are miles. So the possible miles would be 0 miles to 10 miles. And after that, I'm not going to deliver the pizza anymore. And my range is the set of all possible costs. And so the cheapest cost would be $4, and the most expensive cost at 10 miles away would be $14.5 or $14.50. I'm going to do a closed bracket on that because they do deliver if you're 10 miles away. Okay, so the next one I want to, supposing the graph of f is given, I want to describe how the graph is transformed. And so you may have seen this when you have something inside there with the x, we're going to move it to the left and right. So if we add 1, then that's going to move to the left 1 unit. And if I have a plus 3 on the outside of that, that's going to move up and down. So that's going to move, since I have a positive 3, it's going to move up 3 units. Okay, and so that is how that would be obtained. So it would be obtained by shifting the graph left 1 unit and up 3 units. All right, so now I want to graph on the same axes, so I'll color code here. So for this one, I'll do in red. I want to do f of x minus 2, and so what that's going to do is shift to the right 2. And so what I'm going to do on here is I'm just going to take kind of each of these main sort of points here, and I'm going to shift them all to the right 2 units. So we'll go to the right 2 units. Okay, so now we have too much going on here. I'll delete those so we can see. And go back to my red pen here and fill it in. Okay, so there is that one. For this one, I'm going to shift down 4 units. Okay, and so I'm going to take each of these main dots and I'm going to go down 2, 3, 4 units. 4 units down, 4 units, and there. Okay. So the next point says the point 1, 0 is on the graph of h. What point must be located on the graph of h of x plus 5 minus 6? So the plus 5 here is shifting it to the left 5 units, and the minus 6 there is shifting to the down 6 units. Okay, so if I do that, I'm going to shift down 6 units, and I'm going to shift to the left 5 units. Okay, and so then the point here would be, well, so what have I done? On my y, I've gone down 6. So the y coordinate would be negative 6. And on the x, I've gone to the left 5 units. So that would be at negative 4. 1 minus 5 is negative 4. So that's a point on my graph. All right, and so for the next one, I have been given a domain and range for a function, and so then it asks me to find the domain of a shifted function. And so we've got to think about what the shifts are that are going on here. This is going to the left 2 units, and this is going down, or sorry, no, up 5 units. Okay, so the left-right shifts are going to affect the domain, and the up-down shifts are going to affect the range. So the domain of this shifted function, I'm shifting all of my x values to the left by 2 units, so that means it would be negative 6 less than or equal to x less than 4. And my range is going to be shifted up 5 units. So all of those y values I'm going to add 5 to. So my range is going to be 5 less than y less than or equal to 9 plus 5 is 14. Okay, so for this one, I'm shifting to the right 3 units, and I'm shifting up 1. And so my new domain is going to be shifted to the right by 3 units. And so that means I'm going to add 3 to those x values. So negative 4 plus 3 is negative 1, and 6 plus 3 is 9. And then my range, my y values, I'm adding 1 to all those y values. So it's going to go from 1 to 10.